This is our APES project about plastics and endocrine disruptors. We research endocrine disruptors and how they affect the environment in our everyday lives through plastics and other materials. My group is Emily, me, and Avanti. Hope you enjoy.
The big food giants, the pesticide and genetic engineering corporations such as Monsanto, the chemical, cosmetics, body care, food packaging, bottled water, and home furnishing industries, they all have a dirty secret. All of these industries make products that are routinely laced with dangerous, often deadly chemicals called endocrine disruptors. These chemicals can make you fat, diabetic, susceptible to cancer, and infertility. They can cause damaging mental and behavioral changes. Pregnant women who ingest even tiny amounts of these chemicals can give birth to boys with genital deformities and girls who will reach puberty at an alarming young age. Endocrine disruptors are chemicals that may interfere with the body's endocrine system and produce adverse developmental, reproductive, neurological, and immune effects in both human and wildlife. A wide range of substances, both natural and man-made, are thought to cause endocrine disruption, including pharmaceuticals, dioxin and dioxin-like compounds, polychlorinated biphenyls, DDT and other pesticides, and plasticizers such as bisphenol A. Endocrine disruptors may be found in many everyday products, including plastic bottles, metal food cans, detergents, flame retardants, food, toys, cosmetics, and pesticides. The NIEHS supports studies to determine whether exposure to endocrine disruptors may result in human health effects, including lowered fertility and an increased incidence of endometriosis and some cancers. Research shows that endocrine disruptors may pose the greatest risk during prenatal and early postnatal development when organ and neural systems are forming. Endocrine disruptors can mimic or partly mimic naturally occurring hormones in the body like estrogens, androgens, and thyroid hormones, potentially producing overstimulation. They can also bind to a receptor within a cell and block the endogenous hormones from binding. The normal signal then fails to occur and the body fails to respond properly. Examples of chemicals that block or antagonize hormones are anti-estrogen and anti-androgen. They can also interfere or block the way natural hormones or their receptors are made or controlled, for example, by altering their metabolism in the liver.
A wide and varied range of substances are thought to cause endocrine disruption. Chemicals that are known endocrine disruptors include the synthetic estrogen DES, dioxin, and dioxin-like compounds, polychlorinated biphenyls, PCBs, DDT, and other pesticides. Bisphenol A, BPA, is a chemical produced in large quantities for use primarily in the production of polycarbonate plastics and epoxy resins. The NTP Center for the Evaluation of Risks to Human Reproduction completed a review of BPA in September 2014. The NTP expressed some concerns for the effects of the brain, behavior, and prostate glands in fetuses, infants, and children at current human exposures to bisphenol A. Diphthalate, DEHP, is a high-production volume chemical used in the manufacturing of a wide variety of consumer food packaging, some children's products, and some chloride medical devices. In 2016, the NTP found the DEHP may pose a risk to human development, especially critically ill male infants. Phytoestrogens are naturally occurring substances in plants that have hormone-like activity. Examples of phytoestrogens are genocides and daisine, which can be found in soy-derived products. Avoiding endocrine disruptors. BPA. Go fresh instead of canned. Many food cans are lined with BPA. Or research which companies don't use BPA or similar chemicals in their products. Say no to receipts, since thermal paper is often coated with BPA, and avoid plastics marked with PC or polycarbonate, or recycling label number 7. Not all of these plastics contain BPA, but many do. Dioxin. Since the ongoing industrial release of dioxin has meant that the American food supply is heavily contaminated, products including fish, meat, milk, eggs, and butter are most likely to be contaminated, but you can cut down on your exposure by eating fewer animal products. Atrazine. Buy organic produce and get a drinking water filter certified to remove atrazine. Phthalates. A good place to start is to avoid plastic food containers, children's toys, and plastic wrap made from PVC, which has the recycling label number 3. Some personal care products also contain phthalates, so read the labels and avoid products that simply list added fragrance, since this is a catch-all term which means hidden phthalates. Perchlorate. You can reduce perchlorate in your drinking water by installing a reverse osmosis filter. Fire retardants. It is virtually impossible, but passing better toxic chemical laws that require chemicals to be tested before they go onto the market would help reduce our exposure. Lead. Keep your home clean and well maintained. Crumbling old paint is a major source of lead exposure, so get rid of it carefully. A good water filter can also reduce your exposure to lead in drinking water. Arsenic. Reduce your exposure by using a water filter that lowers arsenic levels.
Mercury. For people who still want to eat sustainable seafood with lots of healthy fats but without a side of toxic mercury, wild salmon and farm trout are good choices. Perfluorinated chemicals. Skip nonstick pans as well as stain and water-resistant coatings on clothing, furniture, and carpets. Organophosphate pesticides. Buy organic produce and use EWG's Shopper Guide to Pesticides in Produce, which can help you find the fruits and vegetables that have the fewest pesticides residues. Glycoethers. Avoid products with ingredients such as 2-butoxethanol, EGBE, and methoxydiglycol, DEGME. At the Circular Economy 100, CE100 Annual Summit on June 22, 2016 in London, UK, Pete Myers, founder, CEO, and chief scientist of environmental health studies, gave a talk connecting the dots between endocrine disrupting chemicals and marine plastic pollution. Myers starts by explaining endocrine disruption and the impacts it can have on organisms, adding into infertility, obesity, and hormone-related cancers. Hormones are the signals that tell genes when to turn on and off throughout your life, and EDCs hack those hormonal signs, Myers illustrates. He highlights the acting on the implications of ED science presents an opportunity to reduce disease burdens. Myers refers to the World Health Organization, WHO, EDC report of 2012 finding that ED is a global public health threat. FPF reported, as well as another study finding that the annual financial burden to the European Union due to the exposure to EDCs is at least €157, FPF reported. Next, Myers outlines the ubiquity of exposure to EDCs and the environmental problems of marine plastic pollution. Some plastics are toxic because they are made up of hazardous substances like the prominent EDC bisphenol A, and plastic particles in the ocean absorb persistent organic pollutants, Myers states. Microplastics in the ocean are ingested by marine organisms such as Daphnia, fish, and seabirds. Ultimately, plastic pollutes the food chain and increases exposure to toxic chemicals such as EDCs. Lastly, Myers presents Tiered Protocol for Endocrine Disruption, a green chemistry tool which helps chemists structure their analysis to work with biologists to figure out is this substance likely to be an EDC or not, and design safer chemicals from scratch.
We love apes, and through this project we realized that endocrine disruptors are very harmful for the environment as we encounter them in our everyday lives, from using, writing our pencils with the lead in that to chemicals in different substances, to water bottles, the plastic in water bottles. And by being aware of these different hazardous things and how they work and affect the endocrine system, we can better create a better atmosphere, better world for our lives.
In apes this year, we learned a variety of different things about what can cause us harm and what can not cause us harm and how to protect the environment. But endocrine disruptors, when we did more research about it, we learned that they're just found in everyday products and just can cause harm to various things, animals, wildlife, or the same thing, humans, wildlife, and just everywhere. And we just gotta be careful and mindful when we're using them. Boo endocrine disruptors! They disrupt our lives. Boo!